Hello, everyone, and welcome to the final lecture of the semester. So we did it. We're almost done. Just one more week, and then the week after will be finals week, and then summer break. So just to recap, so today is our final lecture. You'll still have the example homework due tonight at 11:59, but there will not be any homework for this topic. So the homework in this case would just be your ALEX assignment, and that is moved up to be due on Thursday, so the last day of class. And then Tuesday is review day for exam 5, so please let me know if you have any questions. The study guide's up, and the practice exam should be up shortly. And then let's see, and then Wednesday's the test, which is open from 12:30 to 11:59. Make sure you read my email to make sure you have everything. And then Thursday will be the review day for the whole semester. And then the final will be open Friday at midnight, and it closes on Monday at 11:59. So it is a 3-hour test. You have to do it in one setting, but you do get to choose when you take it. But normally we take it on a Saturday, but due to this semester's circumstances, we made it more flexible. And then just make sure that you turn in your scratch work into me, like the other tests. All right. So, but one thing I do want to say is, if there's anything this semester that you had, that you still have questions about, or a certain problem, just let me know, and then we can work on it during my office hours, or I can make a video about it. So just let me know, and then I can do that for you guys. So let's go ahead and get started. So the topic we're going to be talking about today is solving a system of nonlinear equations. So going back to just solving regular systems of linear equations. So this is nonlinear. So what does that mean? Because linear looks like y is equal to mx plus b, or we can look at it standard form, ax plus by is equal to c. So linear means that the x and the y both have a power of 1. But when we solved a system of linear equations, essentially what we found was when those two graphs met. So if I had like y equals x, and then maybe I don't know, like y equals negative x. When I draw that, that's actually an x. And then if this was on a system, then the solution would be 0, 0, because they crossed at that one point. Right, and then remember, there was like the infinitely many solutions when they were the same line, or there was no solutions because they were parallel lines. Right, so that was just a little mini review. So same thing, right, just with nonlinear equations. So let's go ahead and look at example 1, and just we'll talk more about it. So for example 1, we want to solve the following system. We're given x squared plus y squared equals 26, and y plus x is equal to negative 6. So before we solve it, I actually want to graph it just so you guys have a visual idea of what we're doing. So x squared plus y squared equals 26. So hopefully you recognize that by now. When it looks like that, that means it is a circle, and then it is centered at, so hk is equal to 0, 0, and then the radius is equal to the square root of 26. Right? So if I graph that, I'll do that in blue, right? So the square root of 26, so I know the square root of 25 is 5, so the square root of 26 is barely bigger than 5, so I'm just going to count 1, 2, 3, 4, 5, and I'm just going to go a little above. Right, so, okay, so I kind of skipped a few steps. So first you're supposed to graph the center, and then you go left, right, top, bottom by the square root of 26. So let's do that. So I did the top, and then 1, 2, 3, 4, 5. So it's like about right here. 1, 2, 3, 4, 5. So about right here, and then 1, 2, 3, 4. So let's say about right there. Right? So I'm not going to try to draw a circle that big. Right? It's just going to be a disaster. So let's do it this way. Let's see. Make a radius. So I'm going to make a diameter of about 10. So 1, 2, 3, 4, 5, 7, 8, 9, 10. Maybe a little bigger. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so oops. Alright, let's try that. Not too bad. So let me just try match and make it a little bigger. Right. So this is what the first equation looks like. So let me color it blue so you know that that's the first equation. Right. And then this one, y plus x is equal to -6. This, if we write it in as a slope, point slope form, or sorry, the y-intercept form, this is equal to y is equal to -x minus 6. So what does that mean? We're going to start at -6. So 1, 2, 3, 4, 5, 6. Right, and then our slope is -1, so we're going to go down, rise over run, so go down 1 over to the right one, but I don't need to do that. I'm going to actually do it this way. Right, I'm going to go up 1 and to the right, and to the left one. Right, so let's draw that. Oh my goodness, okay, let me restart that. And then let me extend it. And then let's turn this green so we know that this is the second graph. Right? And then there's arrows because this goes infinitely long. Right? So this is what our graph looks like. So what does that mean? That means that when we solve for this, we should have two solutions because it crosses here and it crosses here. Right? So this graph is not the most accurate, and I can tell it's not like in the dead center. So let's find it. Right? So we're going to use the steps I have to the side, and let me erase all of this stuff. Right? And then so when we learned how to solve linear equations, I gave you guys two options. We did substitution and we did elimination. When you solve nonlinear equations, you also have that choice to do substitution or elimination. However, I'm just going to be talking about substitution. The reason why is because you can always use substitution, but elimination, you have to be more careful. Like for example, for example 1, we wouldn't be able to use elimination because there's no common term. Like there's x squared, y and x. Like we can't do that. So yeah, so we're just gonna be learning about substitution. If you wanna learn about elimination, you can go ahead, you can read the book, but today we'll just be doing substitution. Right? So what is step 1? Step 1 says to label our equations. So I'll label this A and this one B. You can label it 1, 2, star, double star, it doesn't matter, just label it. Alright? And then step 2, we're gonna get a variable by itself. So when I look between the equation A and equation B, I'm going to be thinking what would be easier to use for substitution. And I'm going to say B, right? Because these are x squared, y squared, but this one's linear, so x, y. So it's going to be easier to plug in y into here or x into here as opposed to trying to plug in y squared into here. And yeah, it'll just be messy. So we have the choice. So I'm going to use equation B, but now we have the choice. Do we want to use x or do we want to use y? It doesn't matter. I'll go ahead and just use y. So let's do step 2. So step 2, and I'm actually going to get rid of this, right? So for step 2, we're going to get y by itself, so b, b star becomes, okay, this is y is equal to negative x minus 6. Right? Now, for step 3, we're going to substitute the equation from step 2 into the other equation. If done correctly, we should be left with one variable. If it's not done correctly, like if you still have two variables, something went wrong, so we got to go back and check our work. Right? So I'm going to plug b star into a. Right? So when I do that, I get x squared plus negative x minus 6. Quantity squared is equal to 26. Right? So so when I look, we just have the variable x, so therefore we did step 2 and step 3 correctly. So now we're just going to solve for this variable. So we have x squared, and then for negative x minus 6, I'm going to FOIL it. So that becomes x squared plus 12x plus 36 is equal to 26. Right? Remember, this is negative x minus 6, negative x minus 6. Right? And then when you do negative x times negative x is x squared. Negative x times negative 6 is positive 6x. Negative 6 times negative x is positive 6x. And when I add them, I get 12x. And then negative 6 times negative 6 is positive 36. All right? So let's keep going. So then I get, so there's a positive 1 here, right? So if I distribute this, it's all the same, so we can just ignore the parentheses. So if I combine like terms, I can get 2x squared plus 12x, right? And then what I'm going to do, so I notice that this is a quadratic equation, so I know to solve for x, we're going to have to factor. So I'm also going to move 26 over as well, right? So this becomes plus 10 equal to 0. Right. I notice 2, 12, and 10 have a 2 in common, so I'm going to factor that out. So I get x squared plus 6x plus 5 is equal to 0. Then divide 2 to both sides. We're left with x squared plus 6x plus 5 is equal to 0. Right. When I factor this, so this can be factored into x plus 5, x plus 1. When I FOIL it out, I will get x squared plus 6x plus 5. And now we're going to use the zero product property. So this is x plus 5 is equal to 0, or x plus 1 is equal to 0. So therefore we get x is equal to negative 5, or x is equal to negative 1. Right? And that is step 4. Now that we solve for x, so remember we're solving for a system of nonlinear equations. So our answer should look like xy is equal to x naught, y naught. Right? So our answer slash, like maybe multiple. So in this case, we have two answers, right? But they both should be in in point form, right? So we found half of both of our answers. So now we have to find the other half, which is step 5. So we're going to plug the newly found values into an equation to find the values of the other variable. So you have a choice. You can pick the first one, or you can pick the second one. Usually we're going to pick the easier one because then you'll have to square everything, then take the square root, and that's just the. So I'm just going to plug it into B. Right. So for x is equal to negative 5. Okay, we're going to plug it into B. When I do that, I get, so y plus the negative 5 is equal to negative 6 Therefore, we get y is equal to, add 5 to both sides, and y is equal to -1. Right? And then when x is equal to -1, then we'll get y plus a -1 is equal to -6. Add 1 to both sides, we get y is equal to -5. Right? So that means our answer, so xy is equal to -5, -1, or xy is equal to -1, -5. Right? And let's go to my solution, and that is what I get, and that's what I got. So this is our solution. Right? So, and then it holds to this one because after we graph this, so it's like we didn't graph it like super precisely, but we still graphed it. We didn't like just sketch where I just drew a circle, not really, just drew a circle and just put a random line through it. Right? That doesn't tell us anything besides the possibility of what the number of solutions could be. But if you graph it this way, you can kind of see. So this is in the third quadrant, so both the x and y's will be negative. Right? So if you want to make sure that your answer is correct, plug in these values to both, because what makes a point a solution to your system, it has to satisfy both equations. Right? So you can check that to see if this is correct. Right? So that's how you solve a system of nonlinear equations. So now let's do another example. So for example 2, okay, we are given y is equal to the square root of x, and we're given x squared plus y squared is equal to 20. Right? So to graph this, I just kind of do a rough sketch. Right, so not as precise as the other graph. So I know that the y equal the square root of x, that graph looks like this, roughly. Right? And then x squared plus y squared equals 20. So it's a circle, so it's at center at 0. So it's approximately going to look, ooh, that's really bad. Okay, let's pretend that's a circle. Right? So this is a rough sketch of what our graph would look like. So this rough sketch is telling us that we're going to have one solution. All right? So let's solve it. Step 1, we want to label. So I'll label this A and this one B. Right? And then step 2, we want to get a variable by itself. But if you look at equation A, the variable is already by itself. So step 2, done. So now what are we going to do? For step 3, we're going to substitute the equation from step 2 into the other equation. So we're going to plug A into B. And when we do that, we get x squared plus the square root of x, quantity squared, equal to 20. Then I get x squared, square root of x, quantity squared, that is just x. And then since this is a quadratic, I'm going to subtract 20 from both sides as well. So minus 20. Right? When I factor this becomes x plus 5, x minus 4. Right? Use the zero product property, and then I'm going to skip those steps. So then we get x is equal to -5 or positive 4. Right? Now that we found, so remember our solution is a point. So we have the x coordinate, now we need the y coordinate. All right? So let's plug these in. I'm going to use equation A. Okay. So then we'll get y is equal to, I'll tell you, so x, when we use x equals -5, we get y is equal to the square root of -5, right? But what is this? We know that this would be the square root of 5i, but it's not a real number, right? So therefore this is not a solution, right? So now let's plug in x is equal to 4, right? So when we do that, so y is equal to the square root of 4, and that is equal to 2. What does that mean? That means our solution xy is equal to 4, 2. Right? And that makes sense because I know the square root of x is only in the first quadrant. So it can only, so when the circle and the other graph intersect, I know it's going to intersect in the first quadrant. So that's how I know that this is the correct solution. So one thing I want to note though, and I didn't note for the first example, let's say that we decided to plug it into equation B. So the x squared plus y squared equals 20. So let's do that. So x is equal to -5. So into B. When I do that, I get -5 quantity squared plus y squared is equal to 20. When I do that, I get 25 plus y squared is equal to 20. Right? So I get y squared equal to -5. So this is y is equal to plus or minus the square root of -5. So we still know this is not a real number. Right? So this is still not a solution. Right? But let's look at x is equal to 4. Right? When x is equal to 4, we get 4 squared plus y squared is equal to 20. Then I get 16 plus y squared is equal to 20. So we have y squared is equal to 4. Therefore, y is equal to plus or minus 2. Right? So as you can see, we're kind of in a predicament because we're saying that we have our potential solutions. Xy is equal to 4, 2. Xy is equal to 4, -2. Right? So, but if this is why it's good to sketch and have an idea of what graphs look like, because then you can kind of tell which one would be the correct or incorrect answer, right? Or maybe not even that, but just like how many solutions you should have. So this one, we know we should have one solution. So when we're left with 2, it gets kind of iffy. So with this, right? So this is why I kind of like to avoid the ones with the squares, is because there's usually one non-true answer, right? But that's not always the case. So yeah, but that's not always the case. So that's why you would have to plug in this into both systems to make sure that they're correct. Because when you do that, like for example, okay, so I already know that this one's true, right? So let's look at, I'll change to a different color. Let's look at xy is equal to 4, -2, right? So if I plug it in both systems, then we're saying -2 is equal to the square root of square root of 4, and then, okay, sorry. let's check this one first. So if I check in A, okay, but what do I know this is? So -2 is equal to 2. This is false, right? Because this is a contradiction, we automatically know that this is not true, right? Remember, when you plug in an equation, you have to plug it into both to make sure that they're true. But if you get one false equation, you can automatically say it's not a solution. So because it doesn't satisfy equation A, we know automatically that this is not a solution, right? So I think just for best practices, we should check all of our solutions, right? So I already know that these are correct, so I'm not going to go through just the arithmetic to check them, right? But just for your own sake, when you solve these problems, I would check them. So now I know that this can be a little bit of a doozy, so with nonlinear equations. So let's do another problem. Okay, example 3, we are given y minus 4x is equal to 8, and then we're given 12x squared minus 2x minus y is equal to -2, right? So I'm not going to do what do you call it? A thorough or a precise graph, right? But I'm going to sketch this. So I know y minus 4x equals 8, so that's like y equals 4x plus 8. So that's a line, right? So I'm going to draw a line. And then this, I know it doesn't look as familiar, but this is actually y is equal to 12x squared plus 2x plus 2, right? This is a quadratic. Since this is a quadratic and since a is positive, I know that this is a parabola looking up, right? Somehow. I don't know exactly what this is and like where the points are, but I know that this is what the general graph looks like kind of a sketch. So this is telling me that we will have two solutions, right? So let's solve it. So first of all, we're going to label, so A and B. Okay, and then we got it. So we're going to use substitution. So to use substitution, we need to get a variable by itself. So I'm going to do I'm going to get equation A by itself because I think it'd just be a lot easier to plug it in. So I'm going to solve for y. So isolate y in A. Right. Then we get A star. So then that will be y is equal to 4x plus 8. Right. Now when we get a variable by itself, what are we going to do? We're going to plug it into the other equation. And when we do that, so plug A into B. So then we'll get 12x squared minus 2x minus 4x plus 8 equal to -2. Right? So there's a minus here, so what does that mean? I have to distribute a -1. When I do that, I get minus 4x minus 8, and then I'm going to add 2 over as well to both sides, right? Because I know we're going to end up dealing with a quadratic. This is 12x squared minus 6x minus 6 is equal to 0. These are all divisible by 6, so I'm going to take that out. So this is 2x squared minus x minus 1 is equal to 0. Right, so then we get 2x squared minus x minus 1 is equal to 0. Right, and what two numbers? So to factor this out, let's say 2x plus 1, x minus 1. When we FOIL it out, we will get 2x squared minus x minus 1. right? So, and then we're going to use the zero product rule. So dot, 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 and then so you'll get x is equal to negative 1/2 and 1. Right, because remember it's going to be 2x plus 1 equals 0, and then x minus 1 equals 0, and then solve for x. Right, so we found the potential x solutions for our equation. So now we have to find the y coordinates. So to do that, we're going to pick one. So you can pick A or B. I'm going to go with A. Right, so plug, or actually, okay, since there's all this room to the right, I'm going to do it over here. So plug into A. So with x is equal to negative 1/2, what do we get? We get y is equal, or y minus 4 times negative 1/2 equal to 8. So y, and then negative 4 times a negative 1/2, that's positive 2, equal to 8. So we get y is equal to 6, right? And then when x is equal to 1, we'll do y minus 4 times 1 is equal to 8. Y minus, so 4 times 1 is 4. Okay, add 4 to both sides, we get y is equal to 12. So what does that mean? So this, our solutions are, so xy is equal to negative 1/2 6, or xy is equal to 1 12. Right, so that's what I got. So these are our solutions. So don't forget, so because I know you guys, like not everyone, like you guys won't have the solutions, so make sure you check them. Right, so that should actually be step 6, check your solution, but I failed to do that, failed to put it on there. Right, so these are all the examples I'm going over today. So one thing I do want to note before ending this video, there might be times where you're given x squared plus y squared equals 25, and let's say, I don't know, 4x squared plus y squared is equal to 30. Okay, something like this. I really don't know if this works, all right, because I just made it up. So say we had something like this, though. That's telling me, right, so I would have a circle, okay, with radius 5 centered at the origin. And this one, we haven't talked about this. This would be like an ellipse, right? So it's going to be like, okay, so something like this. I don't know, very, very rough. Let me move it and change its color, right? So we could have something that looks like this, all right? And so this shows us that there will be 4 points for solutions. So if you get that on your examples, or if you get it like on your Alex homework, don't fret, because it's just, yeah, sometimes you will get a solution. You will get a solution like this, right? So that is it for today. So if you have any questions, please let me know. If not, you guys have a nice day and the rest of the semester. Bye.